Hello all, very good morning. Thanks for joining the session. Let me share my screen. Let me set the agenda of this awareness program. So first of all, this is an awareness program on the Docker Kubernetes, how they are popular and why everyone is willing to use or trying to use this Docker and Kubernetes, and how it becomes a de facto tool for the developers, testers, or the DevOps engineers. So this awareness program, you will get the complete idea, at least the idea about the Docker and then Kubernetes. And actually, we planned it as two things. One is an awareness program. Second one is right after this awareness program is done, we are will give we will take a 30 minutes of break, and then we will start the Docker and Kubernetes paid workshop. So if anyone is interested and feel like it is helpful, then you can join. However, this is awareness program come paid workshop conducting. Paid workshop will start from the 11 a.m. onwards, and now 9 to 10 or 10:30. Let us go with this awareness program. Fine. So let me try to, of course, by this time, you might already heard about the word called Docker, right? Maybe you might have also have seen various other videos or maybe the documents you followed to understand the Docker. Let me also try to make the Docker understanding much simpler as much as possible. So first, the agenda of it is, let us first understanding the Docker. First of all, how I planned this paid workshop on the Docker and Kubernetes. This is what the content and then the planning. First, we will finish with the Docker understanding and Docker installation, Docker architecture, understand the Docker engine, and then understanding this WSL2. What is the WSL2? And of course, while understanding this bare metal VM, we will understand this WSL2. So what I mean is, this is just to understand what is the problem without Docker and how the Docker given the solution. So such a beautiful solution, how we can set it up on the Windows machine and on the AWS Ubuntu operating system AMI, how we will set up is we will see. Once after we have been done with the setup, then we will understand the Docker architecture and then the Docker engine. So Docker architecture is a client server architecture. What is that? I will explain, but Docker architecture we will understand. Docker engine is what we will understand. And we'll understand the what is Docker and compare the Docker with the existing virtual machines, because here an important interview question is asking by the interviewers now. So though meaning we have already the virtual machines, why we are going for the Docker containers? That is the question actually the interviewers are asking. We already have the virtual machines. Then why we are going for the Docker containers? What benefits we will get? So that is the question they are asking. To understand that question, meaning to answer that question, we need to know all these things. Problem without Docker, solution with the Docker, and all we need to know. So once after this Docker understanding is done, and we were ready with the Docker product installed in your local machine and also on the cloud provider, then let us go and then see the Docker commands. Because throughout whenever you are using the Docker, throughout your Docker usage, we'll operate the Docker with the commands only, because Docker is a client server architecture. Always in client server architecture, client is communicating with the server either with the commands, either with the API. So similarly, Docker is also doing the same. Docker client is also doing the same. So here we will also understand the Docker client. So Docker client is also doing the same. So to speak to this Docker server, Docker engine, the Docker commands. So what are all the commands? All those things we need to see. Because these commands are, you must have these commands handy. Interviewers will ask in the interview or in your day-to-day life while you are working on Docker, these commands will give you a lot of stuff that you can do with the Docker. Then once after these commands and all we understood, then we will go and then understand the Docker core concepts. The core concepts of the Docker is the Docker image, Docker container, and Docker file. Of course, now as part of this problem without Docker and then solution with Docker, right? So here you will understand about the container and then image. But how this container and image will be created, you can understand using this Docker file. So Docker file need to be mandatorily must to be written by the developers and also the DevOps engineers. Nowadays, all the projects who is practicing, 95% of the applications are practicing the DevOps. So who is using the DevOps? Then the DevOps engineers are expecting the developers to write the Docker file, because the developer only know how he has written the application. So that is the reason he can only write the Docker file without any issues, because he knows the better about his application. That is the expectation of the DevOps engineer. So being a developer, you must have to know how to write the Docker file. This is no escaping point for us. Right. So many developers are there, sir. Actually, in my project, my lead is there or my architect is there. They will write. Okay, that is fine. But when you will start writing, why do you give the chance to them? You take the chance and then write the Docker file. What I mean to say is, nowadays, Docker is a mandatory tool for the developers and mandatory tool for the DevOps. When Docker is mandatory, Docker file is the guide or is the basis or blueprint. Main actually, Docker file is, you can say Docker file is hard to create these images and then containers. So how you will expertise on writing the Docker file, that much of comfortable in your work you will get, and then good opportunities also you will get. Then once these Docker containers are created, how those containers will communicate each other, because database is one container you created, application is one container is you created. Then how the application and database will connect together, that is the concept of the Docker networking. So Docker networking will gives us every Docker container will be create one private IP address. So if we have two containers, two different private IP addresses, we will get how the two different containers using two different private IP addresses will communicate each other is the concept of the Docker networking. Without this Docker networking, containers doesn't make sense. So this is mandatory question in the interview. Docker file. One question is on understanding your. One question is on understanding your expertise or your experience on the containers versus virtual machines. That is one damn sure question interviewer will ask you. Second question compulsory you will face on the Docker file, and then the image containers core concepts. 100% you will get the question on the Docker file. Third concept where you will 100% get the interview question is the Docker networking and Docker volumes. This is a beautiful concept. Without these Docker volumes, your containers data will be lost. So these containers, when they will be restart, containers meaning you understand it's like one application. Like Tomcat is one server. We might already know, right? Tomcat probably. So consider like a Tomcat, which will run your application, which is in the var format. Similarly, container also run the application, which is in the image format. So this container, when it started and then stopped, the data inside the container will be lost. To avoid that data losses, we will sync the data with the machine. Okay, simply said, the data losses will be avoided using the Docker volumes. So how the data losses will be avoided using Docker volumes? 100% we have to use this Docker volumes whenever you are using the Docker containers. So if you know, sir, I know Docker file, but I don't know Docker volume, that doesn't make sense. Honestly, that doesn't make sense. Sir, I know Docker container, but I don't know Docker networking. Again, it doesn't make sense, right? So whenever you know something, you must and should have to know everything inside the Docker, because that is expectation of an interviewer, and also being your team member, your lead, or maybe your architect, or if you are an architect, then that definitely be the mandatory skill set, meaning the knowing entire Docker about is important. So we will understand, and then we will do all these things in our weekend workshop on these 5 projects. So we will start Docker file for this static website. We will create Docker image for this one. We will run Docker container for this one. And we will set up the Docker volumes, Docker networking, and all concepts for each and every of this application. So a total of 5 applications we will Dockerize throughout this session. So in these 5 applications, when we are Dockerizing, we will face a problem. What is that problem? Multi-container dependency. If one application is, for example, the Spring Boot application, Java application you take, it is depending on the database. So database is one container. Our Java application is another container. Then how these containers will be managed together? Not only that container, maybe we have the other containers as well. Assume this Spring Boot application is depending on another application, another container called Node.js, where it is getting some data from the Node.js into the Spring Boot, assume. Then how these 3 containers will now manage together? That is called as container orchestration. So that container orchestration we can do using this Docker Compose. So this is the idea of the Docker and experience about the Docker, what you can do with the Docker. Now there is some issues with the Docker containers. So those issues to resolve, for example, we are running our application as a Docker container, but this Docker container is keep on restarting, or this Docker container is when the machine is shutting down, the container is going down, or I want 2 to 3 same containers, same instances of the containers, like 2 to 3, right? So meaning, if we want the more container management, like always available, if one container will fail, in place of it, immediately another container should have to be come up, right? So those are all the things can be do by the Kubernetes. So Kubernetes will manage the containers lifecycle in a more better way using the cluster. So how the cluster, what is the cluster? Again, we will discuss. But for now, let us go and then start understanding what is this Docker, why you guys need to know about the Docker nowadays, and how you will work with the Docker is what we will understand first. Let us see a problem without Docker. So let us see a problem without Docker. First of all, what is Docker? Just a glance definition. This I have copied from the official Docker documentation. So Docker is a software packaging tool to package the softwares as containers. Maybe you might not understand the meaning of it right now. At this moment, when I'm reading this line, you definitely not understand it. I know. But just understand what, just keep these words in your mind. Docker software packaging tool. This is a packaging tool. First of all, Docker is a packaging tool. What is packaging, sir? I'll explain. And what it will package. For example, you wish to travel from one place to another place. What you will do? You'll first pack your luggage, isn't it? Similarly, Docker also pack the software. Why? To ship from one place to another place. Right? So that is what the Docker solve the problem in short. But what does Docker do? It will packaging the softwares. Like how we will package the luggages, how we will package the vegetables when we go to vegetable market, how we will package the the couriers, right? I mean the items inside the courier, how we will package, and how we will package the luggage or the clothes whenever you are traveling from one place to another place. Similarly, Docker is also packaging the softwares. Softwares meaning maybe your Java, .NET, Python, PHP, and Tomcat container, Tomcat server, whatever it is, your code, your source code, meaning your source code, developers usually will write the source code, right? That source code. So everything, it will be packages. It will be packaged. Package into where? It will be packaged into image. Usually when you go to market or when you go travel from one place to another place, where you will package your luggage? In the bags. Similarly, Docker also packaging the softwares in the images. So we will discuss about it going forward. So Docker is a software packaging tool to package the softwares as containers. So which uses the operating system virtualization. This is a little heavy word, virtualization. We will discuss going forward, but at this moment you forget about this. Docker introduced in 2013 by the Docker Inc. Imagine 2013, in 2013, Docker was there. But nowadays people are using, even 2020 also, people were not used Docker that much. But in 2021 late and then 2022 early, since early to so far, Docker is de facto tool. If you are a developer, there might be 100% one question. Do you know Docker? Though your profile doesn't contain the Docker as the skill set, maybe in your experience summary, maybe in your knowledge table, maybe in your any of the projects, though the interviewer don't see a word called Docker in your resume, out of curiosity, he will ask one question. Do you know about the Docker? Why? Why the people are using that much nowadays? Let us try to understand. So Docker can package an application and its dependencies. This you will slowly understand. In a nutshell, you understand Docker is like a packaging tool, which will packages the softwares into an image, which will be run as a container. I'll explain all these things going forward. First, let us understand actually what is the Docker. We know now. Docker is just like a packaging tool. Like how we are collecting the things into a bag, Docker also will collect the softwares into one bag called image. But why we need to use the Docker? Why we need to collect the software, all the softwares and source code? Why we need to collect into a bag? Right? What is the problem without the Docker? Let us try to understand. So in real time, we have the various environments. We know, right? Dev environment, QA environment, QA meaning testers environment. The testers, QA meaning the environment on which the testers will test. Dev meaning the developers will test their applications, like unit testing, integration testings will be done by the developers on this dev environment. Once the developers were done their code writing, unit testing, integration testing and all, then they will be give the code to the QA for functional testing, end-to-end functionality testing. Okay. Okay, so functionality testing. No, don't think Docker as a software build tool. No, it never build this software. Rather, it will packages the software. Building software is different. Packaging the software is different. Okay, don't consider Docker as a software build tool. No, that is wrong understanding. What is Docker? It is just a, see, you are collecting the clothes into the bag. That means, are we manufacturing the clothes? No, never. Clothes were already ready, right? You want to travel from Hyderabad to Bangalore. What you will do? Do you spend the entire night and then stitch the shirt and pant? No, you already have the shirt and pants, or the saris, or maybe whatever the dresses for the girls, for the boys, for the kids and all. You will package readily available items into one bag, and then you will start traveling. Similarly, Docker also do the same. Readily available software builds over there, Docker will package them. Why it will package? To shift from one place to another place. We direct kept jar inside AWS. What is the need of this Docker and Kubernetes? That is what the, you are attending here. I am telling what is need of Docker and Kubernetes. Just listen, you will understand. Okay, fine. So in real time, we have the various environments, namely dev, QA, UAT, and production. So usually developers will write the source code, and all the developer source code will be merged into an integrated environment. So this is the repository, like Git repository, consider. So in Git repository, what we will do, there will be always a main branch which contains the application code. And these guys are the developers. So these developers were assigned with the certain requirements. So what are those requirements? Just in a moment of time, I will show. Just assume what are those requirements. For example, this guy need to work on the login, and just let me open these requirements. One person need to work on the login, one person need to work on the dashboard, one person need to work on the products, right? They're the developers. They need to develop the software, right? So entire software one developer can't develop. So that is the reason it has been divided and distributed among the developers, so that one developer can handle one requirement or two or three requirements. How much he can deliver, those he will handle. So now what will happen here? Each and every developer will get one requirement. Assume this developer need to work on the feature login requirement. This guy need to work on the products. This guy need to work on the dashboard preparation, meaning rendering all the products inside the dashboard. Right. So just let me show the requirements once after this PPT has been started rendering. It is little slow to load these avatars and all. Just let me go little faster and then reach out to this place. Yes, this is what I would like to discuss exactly. So there were a list of requirements we have. Right, so welcome page, login page, dashboard, gallery, list of products. So meaning these are all the requirements, 11 or 12 requirements I want as an application. Then that requirement will be divided among the developers. Maybe one developer will take care of these welcome page, login, dashboard, gallery, and other developers, or maybe, or else 1 week or 2 weeks, these 4 requirements will be handled by the 4 developers. This is a work distribution. So what I mean to say is now that is the case. Then this developer is working on login. This developer is working on dashboard, and this developer is working on the products module. So there is a common code, main branch. So these guys will do what? From the main branch, these guys will create the feature specific branches like login branch, dashboard branch, products branch. Likewise, the feature specific branches these guys will create. And then always the branch will be created from the another branch. So here the bare source code will be there, just a empty application with the folder structure and all will be here. No code assume. So these guys will create the another branch, feature specific branches. He is working on login. So he created the feature slash login, and then he created this branch from this main branch. Similarly, the products is also created, and then the dashboard is also created. They feature specific branches, and then the developers are working on it. Now, once after these developers completed their work, they will push their work to their respective branches. Meaning he will completed the coding, so he will commit his files to his branch only, feature slash login branch. And this guy will commit the code to this product branch. This guy will commit the code to this dashboard branch. Now all these branches code need to be integrated. That is the reason we will use the integration servers. Yes, these will be happen in the Git repository, GitHub, Bitbucket, and all. So this is the source code repository, maybe Bitbucket, Git repository, GitHub. You can consider like anything. Fine. So now what will happen? These developers, once they written the code, they are pushing their individual branches. But combinedly, whatever these guys were done, combinedly we need to check whether all this code is working or not. How? When the user will be logging, he has to go to the dashboard. In the dashboard, he has to see the list of all available products, like how you can see in your Flipkart and then Amazon. Isn't it? Trending products, available products, product based on a particular category, those need to display on the dashboard. So then how this entire flow will work? When all these 3 developers' work will be merged together into one more branch, where that branch contains all these developers' code, then they can test on here. Right? Fine. So this code is merged and then they tested. Okay. Now remember few things here. For example, this developer is working, right? Let us assume all the developers working for a project called retail e-commerce, which is following the entire architecture in client server model using the following technical stack. So the application they are developing is using the Spring Boot, meaning Java, and then Maven as the build tool. And then the Tomcat is the server where they are deploying their application. And then they are using the React.js as their UI application. React is running on the Node.js. And database. So application, this Java application is connecting to this database. So this is the technical stack they need to install everywhere. For example, this is the developer while working in his laptop, he installed all these tools. And he is the developer in his lab, again, he installed all these tools. And this guy also installed all these tools in their laptops. And they work together. They have integrated the code with the UI, and then they have seen their flow. This guy tested login is working. This guy tested dashboard working. This guy tested products working. But combinedly, to connect the flow, like after login, dashboard need to be rendered, and then in the dashboard, products need to be shown. The combined flow to test, we need to combine these all work into a single branch, that is the dev release branch. Now, dev release branch meaning what? Dev release branch also should contain all these softwares, isn't it? To run the application. So what we need to do, we have to go here and then create a dev machine with all this technical stack, right? So when all the developers written code will be merged into dev environment. So we need to do the following activities on the dev environment. Create dev environment machine, virtual machine or AWS machine, you have to create it. And then install the required technical stack, JDK, Tomcat, Node.js, MySQL. So these are all the technical stack we need to install here. And once install here, we need to pull the source code from dev release branch to this. We need to pull the source code from the, okay. So what we can do here, we need to pull the source code. We need to merge the source code, right? Meaning the source code need to be merged. So all the feature specific branches source code need to be merged to this dev release branch. And after that, what we need to do, we need to build the application in this one. And then we will get a jar or var file. So deploy the jar or var file in Tomcat server, right? Then we have to test everything. First, number one, we need to install all the softwares like Java, Maven, Tomcat, Node.js, MySQL. All these things we need to install on the dev environment machine. And then we need to merge the source code of all the developer branches into this dev branch. And then this dev branch code we need to build using the build tools like Maven, Gradle, or Python, whatever the Python PyBuilder or whatever the technology we are using. Accordingly, build tools we need to use and then build the application. Perfect. The application has been built on the dev environment and then tested. Developers were tested. So when the code is integrated on dev environment and unit or integration testing is done by the developers on all these merged features, it will be released to the QA environment, isn't it? Now, once the developers are confident enough, then they will give the code, they will give the QA to start the testing. But the QA, in order to start the testing, what they want? The QA, we need to create one branch called QA release branch. Into that QA release branch, we need to create this QA release branch by pulling the code from the dev branch, which is already tested by the testers. Okay, for this, what we need to do, again in the QA, we need to create one mission. Number one, in that mission, install all the technical stack. That means install the Java, install MySQL, install Tomcat, install Node.js, install Maven, right? All these things we need to install again on the QA machine. Then in the QA machine, we need to get the code from the dev release branch. Again, we need to build it here. Again, we need to deploy in the Tomcat. And then the testers will start testing, right? Fine. Now the test QA code need to be, deployed into the production. So this is the production. Am I audible, guys? Yeah. So this QA code need to be deployed into the production. Now, how they will deploy into the production? Again, so we need to build the production machine, right? Take one virtual machine and then create the, take one virtual machine and then create the, QA machine, like how we created the QA. Similarly, create the production machine, install Java, install Tomcat, install Maven, install Node.js, install MySQL, pull the source code from the QA branch, run the application, build the application, and then run the application. What did you observe all these activities? So if we observe, when any new environment is added, we need to set up the environment specific machine with all the required technical software stack installing on it. So when any environment is changing, then we are pulling the source code and building the code and then deploying the code. What I mean to say is when any environment is changing, when the developers are done their testing in dev branch and then letting the QA to know, like they have to do the functional testing, then what we need to do? The QA branch need to be merged with this dev release branch code. And again, QA release branch code need to be built on the QA machine, isn't it? So if you understand all this process, when any new machine is adding, we are installing all the required technology stack. And when an environment is changing, we are pulling the source code, building the code, and then deploying the code. So this process we are doing iteratively, which causes the below problems. What is the problem? Setting up environment with the required technical stack installation will take some time, right? And it is a repetitive process when any new environment is added. Definitely 2 to 3 days or 3 to 4 days or a week also will take, because a lot of approvals need to get to take one mission, right? So set up one environment, it might take little time. Second one, as we are pulling the source code, building it again and again and each and every environment, there might be a chance of build issues or deployment issues if the stable code is not pulled. What I mean to say is, these developers tested well, the code they were tested well in the dev branch. But while merging this dev branch code with this QA branch code, there were some files missed, assume. Then what will happen? Build might not done here, errors will come here. Or else by chance if the build also done, then definitely one or more functionalities don't work because the merge of the code has not been done properly, or not done, the latest branch merge might not be happened. So this every time pulling the code here and then building it causes the environment incompatible issues if we don't properly merge the code or pull the code. That is the problem number 2 we will face if there will be this repetitive process. So that's the reason maybe the dev release branch code might works well on the dev machine, but the QA release branch code might have some issues on the QA machine, isn't it? So, and third thing is what, we are violating the concepts of the cloud agnostic. So what is the cloud agnostic is suggesting nowadays everyone is building the microservices, isn't it? That means with the motto of the cloud agnostic, we are building the microservices. Maybe I'm using little bigger words. What I mean to say is, if the code will work in one environment, it definitely should have to work in another environments. So that means what, to support this, the cloud agnostic is suggesting few principles to us. What are those? Write once, read anywhere. That means what? Build once your application, and the same build you need to deploy on anywhere, on any environment. So then only you can say it is a cloud agnostic. If you build, what is happening here? And dev we have built the source code. Again on QA we build the source code. Again on production we build the source code. So when environment is changing, we are pulling the source code, building the source code. Building meaning what? Getting the var file, jar file, ER file, or maybe your .NET related build things, or maybe your dist folders if it is in case of UI, right? Or the minification files in the case of the React.js, AngularJS, Node.js. That is called as a build, isn't it? Your entire source code is zipping into small, format which is understanding by the servers. That is called the building. Every time we are building it, which is violating the cloud agnostic principle. So build only once, deploy it every time, everywhere, anywhere. That is what it is. And keep it simple. Keep your environment or code is very simple. But what is happening now? Our environment is very complex, right? So if it is the dev environment, we need to set up all these things. If it is the QA environment, again, we need to set up all these things. If it is UAT, again, we need to set up. Keep it simple. It is not simple. Why it is not simple? Assume I want to introduce one new software here. Then I have to introduce on all the environments, first of all. or I want to upgrade a version of a particular software. I have to do on all the machines, all the environments, which is not so easy. So it is not at all simple infrastructure. But our Vora, our cloud agnostic is saying, keep it simple. So the above three problems will be solved, and the cloud agnostic benefits we can achieve using the Docker. So whatever the three problems we discussed so far, these three problems we can solve, and then the cloud agnostic also we will get using the Docker. One moment. Right. So how the Docker will solve it? How the Docker will solve it is, carefully observe, please. Carefully observe, please. How the Docker will solve it. Same story, but how the Docker will solve it. So all the developers will push the code to the branches, right? And all the source code of the developers will be merged with the release branch, right? Then on the dev machine, we will install all these softwares, isn't it? Still we do the same. On the dev machine, we will install the Java, we will install the Maven, install the Tomcat. At least install the Java, install the Maven, we will do, not Tomcat and all. Then what we will do, whatever the code here we have, that code we will pull into the dev machine, and we will build that code as a jar or var. And here we will install the Docker, and this jar we will package inside the image. And also to run this jar, whatever is required, Java is required, Tomcat is required, whatever are required to run this jar, all those things will be packaged inside this image. Similarly, if it is a UI application, that is a React.js. So React.js application code will be packaged into an image. And to run the code of the React.js, we need the Node.js, that also will be put into this image. And the database is also will be taken into one image. We were not installed these softwares manually here. These softwares already were there inside the Docker. So we are taking them and then attaching our source code to those available softwares. Entirely, whatever the softwares required to build our application, to run our application, those are all the softwares we are packaging into one simple bag called image. So what will happen? Now, what will happen once all these softwares are packaged into a bag called image? What will happen? These softwares, these images, what we will do? We will push into Docker Hub. That's it. Now on QA, what will happen? QA don't install Java, meaning QA machine, what I mean to say. So QA machine, they don't install Java, no need. They don't install the Maven, no need. They just install the Docker and then go to Docker Hub, pull the code, meaning pull the image, run the image as the Docker containers. So run the image as the Docker containers. That's it. Now tomorrow prod also will come. Then what we will do? No need to install Java, Maven, all the technical stuff. No, just install only Docker, connect to Docker Hub, get the images, run the images. That's it. So that is what the architecture exactly here. Tomorrow prod will come. The prod will come. Don't install all the softwares. Now what is happening here? The application packaging inside this image is transporting from one environment to other environments, isn't it? Using the registry. So only one time build is happening in the dev machine, but everywhere, wherever it is required, it is running. Meaning we are writing once, reading anywhere, building once, and then deploying anywhere. Right? We are achieving the cloud agnostic. And also it solves the problem of installing the required technical stack on every machine. No, just install the Docker in QA. That's it. But dev, yeah, dev install the Java, install the Maven, pull the source code, build the source code, and whatever the jar we got, whatever the Node.js files we got, those we need to keep inside the images. Now image contains what? Image contains your build, application build plus to run your application, what is required, that is also there in the image. Plus, if it is a Java application, Java also we will put inside the image. So whatever are required for your application to run, those are all the technologies, softwares, tools we will package inside the image. It is just packaging. But this jar where we are building, the jar we are building here itself only. So using the Maven build tool installed on the dev machine, we are creating the jar file, and the created jar file we are keeping inside this application. And then to run this jar file or var file, whatever are required, that also we are keeping inside this bag. And then finally, this bag we are putting into our registry. And for every environment, whoever want to get this application running on their missions, they simply go to Docker Hub, get the Docker image, run the Docker image as a container. So running instances of the image is said to be a container. Similarly, your Tomcat, what you will do? Your code will be there, right? So what you will do in the Tomcat, your code will be there. Sorry, what I mean to say is, here is your code, isn't it? What you will do in the code, especially Java developers I'm talking about, just for understanding. So here your code is here. You will write your code related configurations in one file called web.xml file. Then what you will do? You will build this code as a var file or jar file, mostly var file. Okay, this is a var file. Maybe it is irrelevant for the other technical stack guys, but for the Java guys can easily understand. So this is the code described into this web.xml file, and then build as a var file, and then it will be deployed inside the Tomcat to run it as a application. So the same var file, whatever has been built, will be deployed in this Tomcat, isn't it? So this is what the var file, this is the Tomcat. Similarly, Docker also do what? In the place of this web.xml file, what we will do is we will write the Docker file. In the place of like how we are building the var file, we will build the Docker image. And in the place of how your Tomcat is running the application, similarly, the container will run this image. So container will run the image. So this container will run the image. Simple. That's it, right? So Docker file, you will instruct what is required. Using that, Docker image will be built. That Docker image will run inside the container. Like how that var file is running inside the Tomcat, similar case. So now probably you might understood how the Docker resolves the problem of repeatedly doing the environment setup and then code moving from one environment to another environment. Here, code is not moving. Rather, code packaged inside one, not code actually, build already done here. Whatever the jar we got, that jar we are packaging inside here. This entire image we are transporting, but not the source code we are transporting. So the problem with the source code transportation is eliminated. What is the source code transportation problem? The problem of source code transportation is merging. So when the QA branch will be merged with the dev branch, the merging might not happen properly. Then the QA branch will get the issues. Again, why? Because we are building the code again here. So that problem is now resolved using the Docker because we are not building the code again and again. Rather, we are building the code in one environment. building it as a Docker image, and then shipping it into the any environments and running the Docker image as a container. Right? So that is what we are doing. Now coming to the definition of the Docker, what is Docker? Docker is a software packaging tool to ship it as a container. To ship it as a container. That is what. Now someone asked me a beautiful question. What they asked is, sir, we have the jar file. In AWS, we can deploy this jar file in the Elastic Beanstalk. Then why we need these containers? What is the need of these containers? We can run the jar file in the Elastic Beanstalk. Elastic Beanstalk is a pre-configured, meaning already set up, right? If your application is Java, then already Java installed, everything is installed there, and which is costly. It's not open source, first thing, which is costly. Second thing is what, we cannot ship. If you want to ship from one environment to another environment, for example, the same jar file you want to run inside the Azure, then what you can do? Similar to Elastic Beanstalk, something you have to find out inside the Azure. But it is not commonly running everywhere. Right? That is not cloud agnostic. But here, once you build this image, the machine which contains the Docker software, everywhere the image will be run. The commands working here also work here. The Docker commands which are using here are same here. Right? Uniformity is there. So across the environments, if we use the Docker, then we will get the benefit of the uniformity. That means working inside one Docker, not working here. No, we don't get that problem. But if you can see, your jar file might work in your Elastic Beanstalk, that is AWS, might not work in the Azure when you go to Azure, because you might need to find out something else in Azure. Maybe it might not work in other clouds. Maybe you need to work on it. So cloud specific it is, but here it is cloud agnostic. That is the difference. Okay, right. So now you might got now an understanding how to, you might now got an understanding like, Docker is a software packaging tool, but not software build tool. We are building the application on the dev environment separately. Whatever the build we got, that build we are packaging. Whatever the readily available vegetables are there, we are putting into our basket, but we are not manufacturing or making the vegetables, right? That is the difference. So Docker is a software packaging tool. Why the software need to package, sir? Because the packaged basket, the packaged bag easily can be transported and can be get onto any other environment and then get out of the application inside in it and then running it as an application, meaning using containers. So entire this discussion, you might understand, keep on two things only: image container, source code, image container. These are only the words you so far understood. You keep on heard these words. And what concept you understood now? Shipping is very easy when we use the images is what you have now understood. And what also you understood, no need to install the technical stack on everywhere if we use the Docker images, because Docker images contains the technical stack to run the application, is what you have understood. This is what you have understood about the Docker, right? So that is our first agenda. Problem without the Docker we have seen, and then solution with the Docker we have seen. So now how do we install the Docker on your Windows machine? So let us go and then see how do we install the Docker in your Windows machine. What are the prerequisite you need to take care of it. Again, I am telling these documents will be available to you if you will be joined. Otherwise, maybe it's not available to you. Okay, so let me open this Docker installation document. How we can install this Docker? Just out of curiosity, you might got an idea. Docker is just, if we install the Docker, we can get the source, we can get the image, we can run it as an application. I don't need to install Java, I don't need to install .NET, I don't need to install any application. One more use case also we can see, for your understanding, the beautiful use case. What is that use case? Maybe this is the .NET application. This is the .NET application. And here I don't need to install the .NET. This is a Python application. Here I don't need to install the Python. This is a React application. I don't need to install Node.js here in this machine. No, I don't need to install. Isn't it? The place where the Docker image is building, that needs to be installed the required technical stack. But the other environments where the image is using is no need to install any technical stack separately on this machine, because required technical stack is coming as part of the Docker image. That's the beauty, isn't it? Isn't it? Lot of work, installation. Basically, the installations doing on these missions are done by the non-technical guys, IT operations engineers, maybe DevOps engineers, right? Non-technical, meaning they don't know Python, they don't know Java, even they no need to know all these things. Simple, you will give one document to them, they will install everything here. While installation, like Java installing here, or Maven installing here, or Node.js installing here, or MySQL installing here. While installing, if they will face any error, again they have to come back to you. You have to rectify it, or again they have to go and then execute the commands. This back and forth communication will eat the time, productivity and all. And finally, end up with error, uninstalling, again installing, uninstalling, again installing. So this is the situation will come mostly in the industries when setting up these upgrade missions, meaning upstream missions, meaning higher environment missions. So now with the Docker, you no need to install. I already pushed here. You run this Docker command. DevOps engineer know about the Docker. Developer also know about the Docker. Developer just will say, I push the code. DevOps engineer will get the code. Problem solved. Right? No back and forth communication. Yes, software packaging means what files will be in. What files will be in is, for example, to run the Node.js, React.js application, what we want? We want the React.js build code. Build meaning what actually? The outcome of the source code. When the source code will be built, one outcome we will get, right? Like jar or var. Similarly, React, maybe dist files. So what this image contains? The build of the source code. And to run the build of the source code, what are the other softwares required? What are the other tools required? Those will be inside the image. For example, if I take this Java image, so I want a jar or var. To run that var, I want a Java installed here, meaning Java required here. And I want a Tomcat here because I want to deploy this in the Tomcat. Tomcat will work on the Java. So all these things we will put inside this bag called as an image. Got it? Right. So yeah, Docker image contains operating system. The beautiful question. Docker image contains the operating system. No, Docker image doesn't contain the operating system. Rather, Docker image will run on the Docker, right? So this Docker architecture, if you can see, there is a WSL2, Windows subsystem for Linux 2. So this contains the Linux directories. So Docker image will be run as a process. Always process will have the access to these Linux directories. So inside this Docker image, the Linux directory structure will be copied, but not the Linux operating system. Got it? Linux operating system, not Linux directories will be there. Again, to run, meaning work with these Linux directories, we have to come to this Docker only. That is the reason there is a driver called WSL2. Of course, you will understand this in the Docker architecture. But as the question asked, the answer is no. Docker image doesn't contain the operating system. Rather than Docker image contains the operating system directory structure. that directory structure will be always same on any Linux operating system, isn't it? So that directory structure, that is a process basically. What is process? Process will always pick your operating system. Where is operating system? Operating system on the Docker. WSL2 is a operating system, Linux operating system. So that will be in the Docker. Now the process will be created here. That process will talk to kernel of this Docker Linux operating system and then get the things to be done within these directories. Beautiful concept, you know. Generally Linux is coming up with a lot of directory structure, but here directory structures are packaging into the images, whereas when the image is running as a container, a process will be opened. That process is talking to kernel and get these directories active. Beautiful concept, right? Yes. Okay, so whoever interested to join. Okay, before that, I would like to answer one more question. Some persons were asked me how to pass the environment variables to this one. So if you can see these environment variables, you can pass. For example, this is the Docker file. So Docker file is always having the environment variables support. So let me just open this Docker file. I will show you how to supply the environment, not this one. Just let me go to the updated things. Let me show you how the environment will be passed. Yes, just go here and just open this Docker file. So this is what we're going to discuss a lot in the weekend sessions, meaning your day-to-day sessions. Now see this, run work directory. This work directory is using as an environment here, and any environment variables are required to this jar or var, you can supply from here. So typically supplying the environments variables to our Docker image will be very easy using the Docker compose file. So environments and all we will supply using the Docker compose file like this. But if this is not there, then how do we supply? Right? So for one container, how do we supply these environment variables? So the environment variables will be supplied using the Docker direct commands called --env. Maybe I can showcase it here. How do we supply the environment variables to a Docker container? Two things we can do. Either we can supply it using the Docker file, or else we can supply it when the Docker image is running as a container like this. Let me open the Docker nodes, microservices and containers. Just I think not this one. Just let me open this. I will answer your question. Okay, so if anyone is interested to join the course, go and then do your registrations. Again, we will be back by the 11 a.m. 11 a.m. and then let us continue with the Docker installations and all. So in a nutshell, the answer, payment details are already sent via over an email. So please go and then check there.
So one question, do we get the recordings?
Yes, recordings will be the recordings will be valid for 2 months. This is not only Docker session, right? Docker and Kubernetes as well. So our weekend workshop is for 3 weekends. Of course, maybe extend to 1 more weekend as well based on our discussions and all. So 1 month will be over here. An extra 1 month recording will be provided to you. Right? Okay. Right.
So one more doubt, sir. So from what time to what time in the morning?
Yeah. So every weekend we will start at 10 a.m. to 2 p.m. 10 a.m. to 2 p.m. Yeah.
Okay.
Okay. Yeah. Yeah. So that's all about this one. And still I have not answered one question, how to set the environment variables. I answered partially. So one, I have shown like, using the Docker compose file, we can set the environment variables. And second thing, what I have to tell you is using the Docker file also, we can set up the environment variables. And the third process is what, using the Docker direct commands we can give the environment variables using -env, like how we are supplying here, isn't it? Like how we are supplying environment variable. This is the database name, this is the app type, this is the port number. All these things we are supplying from the Docker Compose file. Similarly, we can also supply directly using a Docker commands. So yeah, so once you registered, you will get the Docker material. So all the Docker material is here. Once you registered, then you will get this material. Okay, so this material will be accessed till your code's ending, meaning you have to go and then download this material, keep it with you first of all. Okay, so now see this, someone asked me how to pass the environment variables. Did you observe? -env, then environment variable name, and then value of it. We need to pass while running the container. I hope I addressed it, isn't it? Yes. Yes, today class is at 11 a.m. for paid students. So class is again at the 11 a.m. who have done your registrations and all. So again, let us resume back at 11 a.m. So now, yeah, any questions? Yeah.
Are you hear me?
Yes, able to hear you.
Oh, thank you. నా డౌట్ ఏంటంటే మీరు పూర్తిగా లైనస్ కమాండ్స్ చెప్తారా లేకపోతే కొంచెం విండోస్ కూడా కలుపుతారా?
ఇక్కడ మనకి ఏంటంటే మనం డాకర్ వాడుతున్నప్పుడు డాకర్ రన్ అవుతుంది, లైనక్స్ మీద రన్ అవుతుంది ఫస్ట్ ఆఫ్ ఆల్.
ఓకే,
సో మనం ఏం వాడతామంటే డాకర్ కమాండ్స్ వాడతాం. డాకర్ కి స్పెసిఫిక్ గా కొన్ని కమాండ్స్ ఉన్నాయి, మనం ఆ డాకర్ కమాండ్స్ నే వాడతాము. అండ్ హౌఎవర్ అది లైనక్స్ మీదే వర్క్ అవుతుంది కాబట్టి లిటిల్ లైనక్స్ కమాండ్స్ ఆల్సో వాడతాం.
అది ఓకే. అంటే మీరు విండోస్ ఎన్విరాన్మెంట్ లో పవర్ షెల్ వాడి డాకర్ ఇన్స్టాల్ చేసి చూపిస్తారా?
రెండు బోత్.
నా డౌట్ అది క్లారిఫై కావాలి.
both actually most of the work we will do on the AWS machine. So let us take the AWS machine and then do that. So if you can see here, first Windows లో ఫస్ట్ మనం విండోస్ లో ఇన్స్టలేషన్ చేస్తాము, ఎందుకంటే మోస్ట్ ఆఫ్ ది లోకల్ ల్యాప్టాప్స్ విండోస్ ఉంటాయి కాబట్టి. అండ్ విండోస్ లో ఇన్స్టలేషన్ చేసి దెన్ we will do the commands, work out on the commands and all.
Okay.
Then we will go to the Linux, meaning AWS Ubuntu operating system. There again we will install the Docker and then we will work there.
Okay, first doubt clarify. Second doubt ఏంటంటే మీరు ఇప్పుడు చెప్తున్నప్పుడు జావా ఎక్కువ వాడుతున్నారు, నాకే ప్రాబ్లం లేదు, జావా వాడండి. బట్ కంపేర్ చేస్తున్నప్పుడు చెప్తున్నప్పుడు సపోజ్ టామ్ క్యాట్ అన్నారు, టామ్ క్యాట్ దిస్ ఇస్ నథింగ్ బట్ ఐఏఎస్ అని ఒక చిన్న సెంటెన్స్
ఎగ్జాక్ట్లీ
ఈజీగా ఉంటుంది అర్థం అవడానికి. మేము మైక్రోసాఫ్ట్ బ్యాక్గ్రౌండ్ అంతా.
ఓకే గాట్ ఇట్
ఇయర్స్ నుంచి అదే దాంట్లోనే ఉన్నాం.
గాట్ ఇట్
అర్థం అవుతుంది కానీ కొంచెం కన్ఫ్యూజ్ కూడా, ఇది అదేనా కాదా అన్నట్టుగా ఉంటాం.
గాట్ ఇట్
నా రిక్వెస్ట్ ఏంటంటే మీరు చెప్పేటప్పుడు క్లాస్ అంతా కూడా రెండు చెప్పండి, అక్కడ ఈజీగా ఉంటుంది మాకు అర్థం. మీకు ఆల్రెడీ తెలుసు అన్ని,
షూర్
మాకు ఈజీగా ఉంటుంది అండర్స్టాండ్.
షూర్ డెఫినెట్లీ I'll correlate the Java with the other technologies as well to understand. Sure.
మూడో క్వశ్చన్ ఏంటంటే మీరు డాకర్ గురించి చాలా మంది చెప్పారు, ఐ వాంట్ దిస్. మరి కుబర్నెట్స్ గురించి ఎంతవరకు చెప్తారు?
ఓకే, సో Kubernetes యాక్చువల్లీ ఇప్పుడు మనం డిస్కస్ చేసే టైం దట్స్ వాట్ ఐ వాంట్ టు షో కేస్ సంథింగ్. మనం Kubernetes చేస్తున్నప్పుడు ఇక్కడ చూస్తే see this meaning lot of depth we will discuss actually. అంటే ఒక సర్టిఫికేషన్ లెవెల్ డెప్త్ మనం డిస్కస్ చేస్తాము. దానికి ప్రూఫ్ ఏంటంటే, మీనింగ్ ఇఫ్ యూ కెన్ సీ దీస్ అప్లికేషన్, దీస్ ఆర్ ఆల్ ప్రీవియస్ బ్యాచ్ రిలేటెడ్ స్టఫ్ ఇదంతా కూడా. సో ఇఫ్ యూ కెన్ గో హియర్ ది application, so simple to deploy one application, we were written the 5 Kubernetes files, meaning the 5 concepts we correlated, and then these are the mandatory concepts we need to use and then install a simple application. And coming to the database, to install the database to deploy, we have written 7 files. Meaning what actually? There is a lot of concept called namespaces, config maps, config secrets, persistent volumes, persistent volume claims, and then the deployment, and then service, load balancer. All these things in depth we will discuss. So the first proof of it is what? This is what the files we're gonna write. Got it?
Okay, thanks.
Yeah, fine. Okay, so Yeah, great. So whoever have done, let us come back at the 11 a.m. and let us start with the Docker installation in your local. So once the Docker installed in your local Windows machine, then we will understand the Docker architecture like client server architecture. Okay, so then we will practice a few Docker commands to understand the study about the Docker. Then we will install the same on the Ubuntu. Then let us start understanding or Dockerizing the static applications and all 5 applications. Got it. So mean the time you come back, I will push these applications into some Git repository and then make them ready. Anything else for me? Yeah. Okay, folks. Thank you so much for your time. Even though on a weekend you joined, you spared your time with me for 1 hour. Thank you so much for that. And then hopefully see you at 11 a.m. if you are interested. Thank you so much. And the material will be provided through the Google Classroom. Recordings will be given with the validity of 2 months.
One small question.
Yeah.
Today is the first class. I mean, is it a class?
Yes. So last weekend we started, and last weekend again, whatever the theory I discussed with you, right? This 1 hour, I discussed the same theory. And in the last weekend, we have done installation of the Docker in Windows machine only. So now when you join, all you guys will be again connected from here, installing the Docker in Windows machine, because the theory, whatever I explained in 1 hour, I already explained to them in the last weekend. So now all you guys came to the same path. From there, we will take it up. Got right?
Okay.
Yes. Yeah. Any more questions for me regarding the course or anything?
Yeah, I have one query that if someone is not that background, so is it the right path to join this course? Yeah,
First of all, this is not related to a technology.
right.
This is not related to a technology. This is related to how we will make the applications to be built or deploy without depending on the technology stack or technical stack installations and all. So the answer for your question is the motto of this, to know how you can Dockerize different applications. That is the end target. Though you are DevOps engineer, though you are .NET, though you are Java, Python, whatever it is, the ultimate goal is what actually, how you will Dockerize. If you are a DevOps engineer, the ultimate job is what, no matter what the application you will get, but you have to Dockerize it. So how to Dockerize it? What are the elements that we need to understand in Dockerizing it? That is what you will learn it. So tomorrow, whatever the application it is, that will come to you, you will easily Dockerize it. So the concept here you will learn is how to Dockerize the applications. What are the elements that we need to look up to Dockerize the applications? Again, Dockerizing the applications meaning what? Creating the images to package the softwares to run it on any environment. So that is what we're gonna learn here. So no depending on the technology, but usually in real time, the developers also will help us in building these Docker images and all. Okay, so that is the whole and sole purpose.
So one more query: you you are running any of the continuous classes for Docker Kubernetes, respective to the weekend?
Yes. So that is starting from the 19th onwards. 19th onwards at 8 p.m. A regular Docker and Kubernetes batch is starting for the 40 days.
Okay.
Daily.
Any morning slot do you have?
No, actually, don't have the morning slot right now.
Actually, little bit. Okay, fine. So 19 onwards, you are going to start that one, right? So
exactly.
Can I call you? What is your number? I think you have text that number. So I have some query about that. So that's when I want to query that. Is it okay if I'll call you? Which number is that? Your 9297979727 is that? Or what is that?
First of all, actually, that is not my number. That is our backend team number. So I should not give. Yeah, I should not give my number. Okay. So anything else? Whoever have joined, right? For them, we are creating a Telegram link. So whatever the questions, queries you will get, we will discuss over the Telegram. So that facility will provide. But Number sharing is not,
Okay,
it's
fine,
against.
fine.
Yeah.
Yeah, I'll do understand.
Yeah.
So that 19 onwards batch is like it's 1 hour course, or what is that? 1 hour only, right?
Exactly. Every day, 1.5 hour, meaning 1 hour theory discussion, 15
Okay.
minutes doubts discussion, 15
Okay.
minutes revision, what we discussed yesterday.
Okay. So my query, another query is that if I'll join that one, is continuous 40 days it's running, or we have some gap
No,
in
no.
between?
Continuous 40 days except the Sundays. Except Sundays and except the public holidays. And of course, if I will get any urgent meetings
Okay.
and all, maybe class may be postponed, but that can be compensated in our next sessions. Like
Okay,
we can take
that same thing, whatever you are covering here, that same thing is going to cover there, or what is that? That is
exactly
different?
same. Concept is same, content is same everywhere.
Okay,
Everywhere
there
it
is
is
no
same.
more elaboration on that, or is it like it's like same course? What are the curriculum you are having here, and that 40 days are same, or it will be different on 40
No,
days? Because I want.
same curriculum, same course, same explanation. The only difference from here to weekend to the regular is what regular sessions will be only for the 1 hour, but weekend
Okay.
sessions are continuously. We'll spend 4 hours, minimum 4 hours we'll spend. That is the only difference.
Weekend timings.
Weekend timings 11 a.m. to 2 p. Sorry, 10 a.m. to 2 p.m. we will spend, but that is depends. 10 a.m. we will start, and then 1 p.m., 1:30 or 2 p.m. again, based on the digestion, how we are digesting, right? That is also matter. So, but I'm not look. The fee is 3,000. Fee is 3,000. Okay, because
That
it
one
contains.
also. That one also. That 40 days course also.
Exactly. That is also same. Same.
So
Same
it is
fee.
sorry for interrupt. It is different from AWS and DevOps batch which you have started from yesterday. This is separate course.
Correct. Yesterday I was started at 6 p.m. Isn't it?
Yes,
which is good.
I was joined there, so I have confusion there. That is a separate batch, a Kubernetes and Docker, or is included in AWS and DevOps?
No, that is a separate batch which will be started 8 p.m. So your batch will be started 6:30, isn't it?
Okay, so my batch will be started from 6:30, whatever is continued from yesterday, and same thing you will be taught there as well, right?
Correct. That's true.
Okay.
As I am from development background, how much for me?
For developers, actually, it is mandatory tool nowadays, right? So it 100% will help you, because developers, the world is now moving into the microservices. We already know, right? So what we need to do, we need to pack everything inside a container or an image, which is called an autonomous, which is the microservices principle. Microservices principle number 2 is microservices should be autonomous. Autonomous meaning it should have its own source code, it should have its own container, own process, own runtime, own JDK. All this is given by the Docker. So nowadays, to make cloud agnostic applications, developers must have to know about the Docker. So it definitely will help. Got it? Yeah. Fine. Yeah. Yes, that is okay. Whoever have already done the fee payment, no need to do any fee. You just joined back at 11 a.m. Okay. Whoever have joined in the last weekend, let us continue at the 11 a.m. Okay. Right. So that's all from my side, folks. Again, at 11 a.m. we will be connect back. Materials will be given to you. Recordings will be provided for 2 months. Fee is 3,000. Every weekend, let us start from 10 a.m. to 2 p.m. 3 weekends course. If required, we will also extend to 1 more weekend as well. But no compromising on the course content coverage, right? So we have to adhere to the course content coverage. So please be cooperate. If it will be extended to 1 more weekend also, definitely.
Sure.
Okay. Yep.
Thank
Thank
you.
you so much, folks.
One more query. Do you have any prerequisites system for that? Like what the prerequisites like system software?
Got it. So it is what kind of a different tool. Altogether, what we will do, cloud agnostic meaning application independent of it. Whatever the application will Docker is, right? So I believe no prerequisite is required for this one, because separately we will learn it. So if you know Java, if you know Python, if you know .NET, that also That is separate stream. Docker is separate stream. So it is a altogether new kind of learning a new technology or new tool. No prerequisite is required.
And we can deploy this software in AWS cloud also.
Yes.
Instance.
Yes. That is what we will do actually. That is what we will do.
Okay. Fine.
Okay.
Thank you.
Thank you so much. Yeah. Any question?
So can you use the same link for 11 session?
Yeah. So whoever have done the payments, right, for your email, the link will be received by this time probably. Okay. 11 AM link.
ఓకే అండి 11 o'clock క్లాస్ కదా ఇప్పుడు నెక్స్ట్ మనకి
నెక్స్ట్ ఇప్పుడు 11 కి స్టార్ట్ అవుతుంది కదా, సో 11 to మనం 2 డిస్కస్ చేద్దాం ఈ రోజు. రేపు 10 to 2 డిస్కస్ చేద్దాము. అగైన్ నెక్స్ట్ వీకెండ్ అగైన్ 10 to 2 ఇట్లా కంటిన్యూ అయిపోతుంది ఇంకా.
11 కి అడుగుతానండి, సబ్జెక్ట్ మీద డౌట్ ఉంది చెప్పు.
షూర్
ఇంట్రడక్షన్ క్లాస్. ఓకే అండి.
యా ఓకే folks, yeah, thanks for your time. Though it is weekend, you spare your 1.5 hour time with me. Thank you so much for that and hopefully see you.
Yeah, thank you.
Thanks.
Yeah, thank you.
Thank you.